Hello everyone. Today we will start solving some numerical problems on wave equation and solution and the relation between wave numbers in a homogeneous medium. So our first problem states that we need to show that for any lossless non-magnetic dielectric, K is equal to K naught multiplied by root under of epsilon r, eta equals to eta naught divided by root under of epsilon r, lambda is lambda naught divided by root under epsilon r, and Vp, that is the phase velocity, is equal to C upon root under epsilon r, where epsilon r is the dielectric constant and K naught, eta naught, lambda naught and C are the intrinsic parameters of vacuum. So let us start solving it. Fine. So to start with, we know that K is given by root under minus of z cap and y cap, where K is wave number and z and y is impedivity and admittivity of the medium respectively. So substituting the values for z and y, we get K equals to square root under minus of z omega mu, and substituting for y is sigma plus j omega epsilon. Fine. Now we know that for lossless non-magnetic dielectric, sigma is 0, epsilon is epsilon naught multiplied by epsilon r. Therefore, the first thing that we need to prove is K. So we can write that K equals to, substituting for z and y, minus j omega mu. Sigma in this case is 0, so this is 0, plus this will be j omega, in place of epsilon we are writing epsilon naught epsilon r. That gives us omega square mu naught epsilon r square root, that is equal to K naught root under of epsilon r. So see, we get K equals to K naught root under epsilon r. The first thing is proved. Fine. Now the next thing, eta, it's the given as z cap by y cap root under. Now again substituting for z and y, we get j omega mu naught by sigma plus j omega epsilon naught epsilon r. Fine. Now again sigma in this case will be 0, so we have j omega mu naught by j omega epsilon naught epsilon r. Okay. this gives us this will j omega cancel out, and we are left with eta naught upon epsilon r. Fine. So, this is also okay. For the next part, we have lambda we know is 2 pi upon k. So, substituting for k from A, like we got k equals to k naught epsilon r. So, we will substitute in place of k, we will get 2 pi by k naught under root of epsilon r. So, k naught again can be written as 2 pi epsilon. So, this will cancel out and we were left with lambda naught upon root over of epsilon r. So, again this is proved. For the next part, that is d. D is phase velocity Vp. So, Vp phase velocity we know is omega by k, that is omega naught upon k naught epsilon r, that gives us c naught upon epsilon r. So, this is also proved. Okay. So, the first problem is solved. Moving on to the next problem, we have for the fields of the standing wave, we need to calculate the velocity of propagation of energy. Okay. So, we will start solving the second one. Fine. So, we need to find out the velocity of propagation of energy for a standing wave. Okay. So, the fields of a standing wave can be derived as, okay, first of all, the velocity of propagation of energy is given by power flow density divided by energy density. Fine. That's equal to S by WE plus WM, where WE and WM are the electric and magnetic energy densities. Fine. So, now to calculate the velocity of propagation of energy, we need to find out WE and WM as well as S. So, to start with, we will first find out the fields of a standing wave. So, the fields of standing wave can be derived as, we can write like, suppose we can write Ex equals to Ex plus Ex minus, that is equal to A e to the power minus jkz plus C e to the power jkz. Okay. Here the superscript plus denotes a plus z travelling wave and the superscript minus denotes a minus the travelling wave. So, similarly, Hy can be written as Hy plus Hy minus, that is A by eta e to the power minus jkz minus of C by eta e to the power jkz, where A and C are the respective amplitudes. Fine. Now, we will impose the condition as imposing the condition A equals to minus C equals to J E naught by 2. Since they are out of phase, we will get Ex as J E naught by 2 e to the power minus jkz minus J E naught by 2 e to the power jkz. That gives us J E naught by 2 e to the power minus jkz minus of e to the power jkz. Now, solving this, we can write J E naught by 2. So, e to the power minus jkz can be written as cos kz minus j sin kz. So, e to the power minus jkz is cos of kz minus j sin kz minus of cos kz plus j sin kz. Now, simplifying and opening the braces, we get J E naught by 2 minus of 2 j sin kz. So, this 2 gets cancelled out and we get Ex as E naught sin of kz. Fine. So, we denote this equation as equation number 1. Now, similarly, we will calculate Hy. Fine. So, to start with, we can write Hy is J of E naught by 2 eta e to the power minus jkz plus J E naught by 2 eta e to the power of jkz. Again, simplifying it in a similar manner, we get J E naught by 2 eta, and this e to the power minus jkz will be cos of kz minus j sin kz plus e to the power jkz will be cos kz plus j sin kz. Fine. Thus, this j sin kz gets cancelled out and we are left with J E naught by 2 eta 2 cos of kz. This 2 cancels and we are having H of y is J E naught by eta cos of kz. Okay, let's denote this equation as equation number 2. Now, Ex and we are having Ex and Hy. Now, we will find the instantaneous fields. Therefore, the instantaneous fields are given by The instantaneous fields are given by, like, Ex is root under 2 real part of Ex e to the power of j omega t. Okay, so we can write it as root 2 real part of Ex, like we got Ex as E naught sin kz, right. So in place of Ex we will write E naught sin of kz e to the power of j omega t, that equals to root 2 real part of E naught sin kz e to the power j omega t. We will write it as cos of omega t plus j sin omega t, that is equal to, we will take only the real part. So we will have root 2 E naught sin of kz cos omega t. So this is the instantaneous field. Denote this as equation number 3. Similarly, we will find the instantaneous H field, that is H of y is given by root 2 real part of hy e to the power of j omega t, right. So again substituting for hy, we got hy as j e naught by eta cos of kz, right. So we will substitute hy, in place of it we will write root 2 real part of, in place of hy we will write j e naught by eta cos of kz, and then e to the power j omega t, right. Next we will write it as root 2 real part of j e naught by eta cos of kz, and e to the power j omega t, we are writing it as cos of omega t plus j sin omega t. Okay. Now we will take the real part. So real part is, we will have root 2, this minus j squared, its minus sign, this minus is due to this j into j square, then real part is E naught by eta cos of kz sin omega t. Let us give this equation as equation number 4. So now we have derived the instantaneous fields Ex and Hy. Okay. Now we will write the electric and magnetic energy densities, that is We and Wm. So we will write it as the electric and magnetic energy densities, the electric and magnetic energy densities can be written as We, that is electric energy density, is given by epsilon by 2 into E square, that is equals to epsilon by 2 E square. Okay, this instantaneous E field we have derived it as root 2 E naught sin kz cos omega t, that is from equation number 3. So substituting from 3, we get in E square as 2 E naught square sin square kz cos square omega t. Fine. So this 2 cancel out and we get We as epsilon E naught square sin square kz cos square omega t. So, we denote this equation as equation number 5. Similar manner, we will also calculate Wm. So, Wm we will have, Wm is mu by 2 h square. Okay. Therefore, again substituting for the value of h from equation number 4, we will get mu by 2 multiplied by h square, that is 2 E naught square by eta square cos square kz sin square omega t. Okay. So, 2 cancels out, we will get mu E naught square by eta square cos square kz sin square omega t. Fine. Now, we also know that eta square is mu by epsilon. Therefore, we can write Wm as epsilon, in place of eta square we are substituting mu by epsilon. Okay. So, epsilon gets cancelled out, mu gets cancelled out, we will left with epsilon E naught square cos square kz sin square omega t. Let us give this as equation number 6. So, now we have We and Wm. Now, we will calculate S. Okay. So, S is given as E cross H. So, we will have like Ux, U cap y, U cap z, we will having Ex, y, Ez, again Hx, Hy, Hz. Fine. That is equal to, for Ux, see here Ey, Ez is not there, Hx, Hz is not there. So, we will calculate as Ux, we will get U of x is 0 plus Uy is also 0 plus Uz we have Ex multiplied by Hy. Fine. Therefore, we can write S as minus of Uz, because Ex and Hy we are having one minus sign. So, we will have Ex multiplied by Hy. So, we will get from multiplying equation number 3 and 4. Okay. So, Ex multiplied by Hy, we will get minus of 2 E naught square by eta sin of kz cos of kz cos omega t sin omega t. So, in this 2 we can write sin kz cos kz, and this 2 we can write it as sin 2 kz. This one and this one we can write it as sin of 2 kz, and again taking 1 2 we can write this as sin of 2 omega t, and that comes out as E naught square by 2 eta. Okay. So S is minus u of z E naught square by 2 eta sine of 2 kz sine of 2 omega t. We will denote this expression as equation number 7. Now we will calculate the velocity of propagation of energy. Okay. So we can write like this: velocity of propagation of energy, we know it is given as by VE equals to power flow density divided by energy density. That is ratio of S by WE plus WM. Okay. So we are equipped with S, we are equipped with WE, and we are equipped with WM. So just we will substitute the individual values. That is equal to, so S we got minus of E naught square by 2 eta sine of 2 kz sine of 2 omega t, right, divided by epsilon E naught square, that is WE. WE we got epsilon E naught square sine square kz cos square omega t plus again epsilon E naught square cos square kz sine square omega t. So basically what we did, we substituted the value of S and WE and WM. Okay. Now we need to simplify this equation. So we can write it as, so E naught square will get cancelled out. We will be left with minus of sine 2 kz sine of 2 omega t by 2 eta into 1 by epsilon sine square kz cos square omega t plus cos square kz sine square omega t. Okay. Now in order to further simplify, we are, let this be considered as A. Fine. So we will write, or suppose we write it as, we denote it as x, suppose. So we now solve this x. Now let x be sine square kz cos square omega t plus cos square kz sine square omega t. Fine. Now we know that we can write cos 2 theta as 2 cos square theta minus 1 and minus and 1 minus 2 sin square theta. Okay. So using this trigonometrical identities, we will simplify this as, we can write x as, so in place of sin square kz we will write 1 minus of cos 2 kz by 2 multiplied in place of cos square omega t we will write 1 plus cos 2 omega t by 2 plus 1 plus, for cos square kz we will write 1 plus cos of 2 kz by 2 multiplied by 1 minus cos 2 omega t by 2. Okay. Now, therefore, we can simplify it as 1 minus cos of 2 kz 1 plus cos of 2 omega t by 4 plus 1 plus cos of 2 kz multiplied by 1 minus cos of 2 omega t by 4. So, we will just multiply and open up the braces, then we will get 1 for this one 1 plus cos of 2 omega t minus cos of 2 kz minus cos of 2 kz cos of 2 omega t, right. Then plus 1 minus of cos 2 omega t plus cos of 2 kz minus cos of 2 kz cos 2 omega t. Okay. By 4. So, this term cos 2 omega t gets cancelled out, this cos 2 omega t and this cos 2 omega t cancel out, and again this cos 2 kz cancels out. Okay. Now, we will have 2 minus of 2 cos of 2 kz cos of 2 omega t, okay, divided by 4. This is what 1 minus cos of 2 kz cos of 2 omega t by 2. Okay. So, now after this simplification we will substitute this value in place of VE. So, now let us see what happens. Substituting this value in VE, we get minus of sin 2 kz sin 2 omega t by 2 eta multiplied by 1 by epsilon, and this we simplified as 1 minus cos of 2 kz cos of 2 omega t, this 2 will go upwards, okay, and this 2 we can cancel out, and thus we will have it as minus 1 by eta epsilon sin of 2 kz sin of 2 omega t divided by 1 minus cos of 2 kz cos 2 omega t. So, this is the velocity of propagation of energy. Okay. In next class we will also solve some few more problems. So, thank you.